Alright, let's get right to it, man. I believe today is let me check, man. Give me 1 second. Today we are on day 15. Excuse me. Day 15. Right? Right. Yup, day 15 now. So we were 2 weeks consistent. Yeah. Had a long day today. But yeah, let's get straight to it, man. Let's get straight to it. Let's see how much I can do today. So we finished merge sort, but the thing is that I want to do is I just want to review it. Cause off stream yesterday I tried to solve a problem with merge sort and it's kind of different, but it's okay. Anyways, so the code that we did, what this does is if the length of nums is less than 2, it should already be sorted. That's what that code does. So first and second, these are the first half of the list, and this is the second half of the list. Then this returns the merge of the first and second. Boom. Now we have something here. So final, we want to get the final merged list right here. All this does is puts these two merge lists together. So I is 0, j is 0. While I is less than the length of first. Because if it's greater than, there'll be... Right, okay, the j is less than. So if first I is less than or equal to second j, append first I and then put +1 here. Else... Yeah, so we gotta see if this is greater than the list, because we just removed one. Okay, boom. Finally, this right here says if I, while I is less than the length, it's not greater. Okay. Then you just append that. Okay. Alright, my bad. I was just reviewing. So now we're on insertion sort. How much is there in insertion sort? This. Let's see. Big O, my insertion sort. We have quick sort. Damn, we're doing all of these joints. Insertion sort, quick sort, fixing quick sort. Alright, so I guess it's just insertion sort and quick sort is what's left. So yeah. Insertion sort builds a sorted list one item at a time. It's much less efficient on large lists than merge sort because it's O and squared, but it's actually faster. Not in big O terms, but due to smaller constants than merge sort. Okay, let's watch the video. I think they'll explain.
First, let me talk about when and why you would actually use insertion sort, and then I'll break down the algorithm step by step. Insertion sort is interesting because it's actually really slow in the average case, order n squared. But it has a niche use case where it's actually used in the real world because of how fast it is. And that's when the data is already mostly sorted and when the data set is very small. Some sorting libraries will actually use insertion sort when the data set is small enough and fall back to a different algorithm on larger sets. So how does it work? Well, it's actually one of the simpler algorithms. We start with an unsorted list of numbers. We'll iterate over each index or each position from left to right. And we're going to keep track of 2 indexes, I and j. I will be the index of the current number that we are on, and j will start at that same position, but it'll actually move to the left. I'll show you in a second. Now, because it's a look back algorithm, we can actually skip the first index. We'll set I and j equal to position 1, or index 1, which is, of course, the second position. Now, the number doing the swapping will be the number at j and the number at 1 less than j. I actually has nothing to do with the swapping. It's just kind of keeping our place in the algorithm. So we look at the number at position j, at the number at position j minus 1. And if they're out of order, we're
Okay, just a little bit confused.
on. And j will start at that same position, but it'll actually move to the left. I'll show you in a second. Now, because it's a look-back algorithm, we can actually skip the first index. We'll set I and j equal to position 1, or index 1, which is, of course, the second position. Now, the number doing the swapping will be the number at j and the number at 1 less than j. I actually has nothing to do with the swapping. It's just kind of keeping our place in the algorithm. So we look at the number at position j, at the number at position j minus 1. And if they're out of order, we're going to swap them and decrement j. If they're already in order, then we can just move on and increment I. And whenever we increment I, we also move j back up to where I is. It seems really fast at first because I and j are close to the start of the list, so the amount of backtracking j has to do isn't very much. But you'll notice as I and j get larger and larger, we're gonna have to look back through more and more of the list. Now here's what a sped up version looks like on mostly sorted data. Here's what it would look like on completely random data. And here you can watch it be really slow on reverse sorted data.
Okay. The only part I'm not understanding really is the I and J part. That one's a bit confusing to me. But I guess we can look at the assignment. So our influencers right there. So for each index, so for num and nums, for num in range, oh man. Free Python ID online. I need to save this, man. Fuck. I guess we can have nums like that. So so four nums in range one print num should be 0 to 8. Okay, so 2, 4, 6, 8. 8. No, it's 9 with 0. Yeah, right. Okay, this works. Okay. Set j variable to the current index. So j is equal to num. And then while j is greater than 0, isn't the +1 though? Well, j is greater than 0 and the element of index j. Well, j is greater than 0 The element of the index j minus 1. So nums j minus. Does this work? I don't know, but we're gonna try. It's so I guess oh j is greater than the element at index j. Okay, where's the fucking I? Does this mean I? Should be. Yeah, J is greater than the element. Okay. Swap the elements at indices J and. Okay, I remember how to do this. It was nums swap. Decrement J by 1. So J minus equals 1. Return nums. Obviously it's not gonna work. Sorry. Where? Yes. So I guess that doesn't work. Can I go like that? Oh. I need this parenthesis. Ba, 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 da, ba, ba. Yeah, that's what I was trying to do. Right here. Index of you're using j equals nums, but j should be an index, not a value. If it should be an index, then yeah, it's not a value. Fuck, read it right, Marty. J should be an index. No value. Swapping logic. The way you're swapping logic is off. You need to directly swap elements of the index, j and j minus 1, by calling them like functions or trying to compare them with equal. Yes, yeah, so I was right at the beginning. It should have been that. I don't know why the fuck the terminal said that. Okay. Syntax is nums, j minus 1. My bad about the stupid dog in the back, man. I don't know how that's wrong. I gotta switch nums, that, and that. I gotta do nums. Oh, stupid dog, man. Sorry, guys. Damn, I need to download Vim or something over here. Oh, no. I don't want it. Yeah, I never understood why it was like that. While J, so the current index. J is gonna be the index. So it's gonna be 0. Yeah. I think that's right. Oh. need to check if j is greater than 0. Oh, okay then. It's not saying the index. These instructions suck. Well, j is greater than 0. Because you're using j as next. Nums j. If the index yeah, I'm subtracting. Yeah, see, that's what I'm saying. So it has to be on the inside, right? Okay. Right. Now this is an issue here. Now swapping. Should be nums j. So it should be nums. Alright, yeah, nums j. I don't even need this parenthesis though. Nums j. Nums j, yeah, minus 1. Now we flip these. Gotta be equal to nums j minus 1 nums j. Alright, let's see how they solve that. Let's forget the I, the num. I was so confused. Where the fuck was the I? And he was saying I was the index. Fuck. I should just put I. Yeah, wouldn't make sense. I don't know why I put num. Fuck. I'm not getting the actual value. I'm trying to get the index, so we should have put I. That was on me. Alright. What insertion of what is the insertion source big O complexity on a pre-sorter? On a pre-sorted? Not constant. There's no way it's constant. How's it fucking constant? Mini production, sorry. Use insertion. Sorting implementations use insertion. Crash out, bro. Is it useful in production systems? Yes. Small inputs? Yes, but only very large. Well, only a small. Which algorithm uses the least memory, which is generally faster, respectively? Well, Well, the least memory is insertion sort. But then merge sort, yeah. Now we're doing quick sort. I think I'm gonna just stop here so I can go work on some stuff solo. I gotta apply to some stuff and reevaluate my life. Tomorrow I'll do a quick sort. Hopefully a longer video. I don't have nothing to do tomorrow, so yeah. Tomorrow, aiming for a 2-hour video. I'm trying to do my longest video tomorrow. So yeah, today I'm gonna just stop at 25 minutes. I should have done longer today. I just had to work today and do some stuff, so I apologize, everyone. Tomorrow, hopefully I can finish all of this, and then maybe start a little bit on exponential time. This doesn't look that long, so we can learn this as well. Yeah, it doesn't look bad. Yeah, this I can 100% finish tomorrow as well. So goal tomorrow is finish all of sorting algorithms and then finish exponential time, and then we'll on Wednesday, for sure Wednesday we'll start the actual day structure. I actually want to read this real quick. Starting with this chapter, we're going to focus on how we can store and organize data in a way that allows us for even better algorithms. Data structures are just organizational tools that allow for more advanced algorithms. For example, stacks, last in, first out, first in, first out. I think, honestly, I'm gonna have a notebook and start writing stuff down just to understand it, or like a whiteboard thing, because I'm gonna start using the Excel draw. And actually I need to like wipe this out because there's a whole bunch of like stuff I used to like learn Python with, so we can make a new one here. I don't know how. I'll figure it out on my own, but yeah, I'm thinking to write stuff down to track my progress, understand stuff, because writing stuff down and understanding how like redraw and like do stuff, it makes way more sense. So yeah, alright, that was today's video. We learned insertion sort, so hopefully you learned stuff with me. I kind of understand it. It's just checking the indexes right next to you, seeing if they're together, boom. If they're less than or greater than, switch them. But yeah, thank you for watching this video. Hopefully you learned. If you want to shoot a comment down below, I'll respond. So yeah, thank you guys. Hey, join the Discord, by the way. It's in my bio. Alright, bye guys.